Now guys, it's time to solve question number 31. This is a 3-marker question and the question states, given that root 3 is an irrational number, show that 5 plus 2 times root 3 is an irrational number. This question is from chapter Real Numbers and the topic is irrational number. Let's solve this question. First, we are assuming 5 plus 2 times root 3 be a rational number. Why? Because we are going to solve this question using contradiction method. So that's why we have assumed that 5 plus 2 times root 3 is a rational number. Now, as per the definition of a rational number, we can convert it in form of P upon Q, provided Q is not equal to 0, where we have assumed P and Q are integers. So, as per this assumption, we can represent 5 plus 2 times root 3. This is equal to P upon Q, where P and Q are co-prime integer. What do you mean by co-prime integers? The HCF of P and Q must be 1. So here we can represent HCF of two numbers P and Q must be 1. Then they are said to be forming a pair of co-prime numbers. I hope it is clear. Now, in the next step, we will be simplifying this 5 plus 2 times root 3. This is equal to P upon Q. And we are getting this expression 2 times root 3 is equal to P upon Q minus 5. And finally, we are getting root 3 is equal to P minus 5Q divided by 2Q. With the help of this final expression, we can say our numerator on the right hand side is an integral value. And the denominator is also an integer. Why? When we subtract two integers, the result is always an integer. And in denominator, we have 2q. When we multiply 2 to any integer, again we are getting an integral value. And on the basis of this expression, we can conclude this very important thing, that is P minus 5q divided by 2q is a rational number. As we proved earlier, numerator is an integral value and denominator is a non-zero integral value. So we can say the right hand side is a rational number. But on the left hand side, we are getting an irrational number. So here we can further write the left hand side is a irrational number and the right hand side is a rational number, which contradicts our assumption. That means we have assumed that 5 plus root 3 is a rational number was incorrect. And what we are getting? 5 plus 2 times root 3 is an irrational number. And this is the proof of this question. I hope you understood this. Now friends, let's talk about the marking scheme of this question based on the concept of real numbers. तो बात करते हैं पहले स्टेप से. जब हमने अज्यूम किया 5 प्लस 2 टाइम्स रूट 3 इज इक्वल टू P अपॉन Q, तो ये स्टेप आपको हाफ मार्क देगा. अगले स्टेप में जब हमने ये डिफाइन किया कि P एंड Q आर को प्राइम इंटीजर्स, दिस इज अ प्रॉपर्टी ऑफ रैशनल नंबर, सो वी कैन गिव half a mark to this step. Now, the calculation part gives you half mark when we are getting root 3 is equal to P minus 5Q divided by 2Q. Then we are getting half mark for this step and half mark when we are concluding that our left hand side is an irrational number while our right hand side is a rational number. This will give you half a mark and rest half mark is based on the final conclusion. I hope you understood कैसे इस क्वेश्चन को आंसर करना है और इसकी मार्किंग स्कीम भी आपको अच्छे से समझ में आई होगी. तो चलते हैं इस क्वेश्चन के ऑप्शनल पार्ट की तरफ, जो कि इसी चैप्टर से है, रियल नंबर से, बट द टॉपिक इज डिफरेंट, दैट इज यूक्लिड्स डिवीजन एल्गोरिथम. So let's read this question. Here it is given that an army contingent of 612 members is to march behind an army band of 48 members in a parade. The two groups are to march in the same number of columns. Notice this statement, they are marching in the same number of columns. What is the maximum number of columns in which they can march? Again, a 3-marker question. Chapter is same, real numbers, but the topic is different, Euclid's division algorithm. So let's solve this question. First, Here we have to find the HCF of two numbers 612 and 48. The HCF will be the required answer for this question. And we will be finding the HCF of these two numbers using the concepts of Euclid's division algorithm. So let's proceed to the next step where we are going to apply the Euclid's division algorithm using the concept of Euclid's division lemma. So we have considered this number 612 as dividend, 48 as divisor. When we divide 612 by 48, we are getting 12 quotient and remainder 36. Friends, we can notice one thing here, remainder is not equal to 0. That means we have to proceed for the next step. And for the next step, we are considering 48 as dividend and the remainder of the previous step as divisor for the next step. And when we perform this division, what we are getting, 1 as quotient and 12 as remainder. Again, remainder is not equal to 0. That means we have to proceed for the next step. And when we divide 36 by 12, this time we are getting quotient 3, remainder 0. That means this is our final step of algorithm. And the divisor of this last step will give you the HCF of the given two numbers, that is 612 and 48. So here we can conclude that the HCF of 612 and 48 is 12. Maximum number of columns in which they can march is 12. And this is the answer for this question. So here we can write the answer for this question is 12. I hope it is clear to everyone. Now let's talk about the marking scheme of this question. 3 marks का ये question था. तो सबसे पहले हम पहले स्टेप की बात करेंगे. जब हमने ये डिफाइन कर दिया कि वी हैव टू फाइंड द HCF ऑफ दीज टू नंबर्स टू गेट द आंसर फॉर दिस क्वेश्चन, तो ये एक इंपॉर्टेंट स्टेप है, तो इसके लिए मुझे हाफ मार्क मिलने चाहिए. अगले स्टेप में जब मैंने यूक्लिड डिवीजन एल्गोरिथम अप्लाई किया तो वहां पे मुझे हाफ मार्क मिलेगा. इसके अगले स्टेप पे हाफ मार्क, अगले स्टेप पे हाफ मार्क, एंड व्हेन वी आर गेटिंग द फाइनल HCF, this will give you half mark and rest half mark is based on the final answer. So I think आपको क्वेश्चन अच्छे से समझ में आया होगा और इसकी मार्किंग स्कीम भी आपको अच्छे से क्लियर होगी. अगर आपने इस तरीके से आंसर किया है, so you are going to score 3 out of 3 for this question. I hope it is clear. Now let's proceed to the next question. Now let's discuss question number 32. This question states, prove that in a right triangle, the square of hypotenuse is equal to the sum of the squares of the other two sides. So this is a very familiar question, or you can say this is a Pythagoras theorem. It is given in your NCERT book, one of the theorems in chapter triangles. Let's prove this Pythagoras theorem. In a right triangle, the square of hypotenuse is equal to the sum of the squares of the remaining two sides. So first of all, let's talk about the given information and what we have to prove and the step of construction. We need construction to prove this result. The given information is ABC is a right angle triangle, right angled at B. What you have to prove? The square of hypotenuse, that means AC square for this given figure is equal to sum of the squares of AB and BC. Here we have drawn BD, that is perpendicular to the hypotenuse AC. So this is the step of construction. Now let's talk about the proof, how we can derive this Pythagoras theorem. So friends, we have started from triangle ABC and triangle ADB. In triangle ABC and ABD, if I consider this angle as alpha, so what about this angle? This would be 90 degrees minus alpha. This one is alpha and this one is 90 degrees minus alpha. So first we have considered the complete triangle ABC and triangle ADB. These two triangles are similar. Why? Angle A is common and the measure of angle ABC is equal to measure of angle ADB equal to 90 degrees. They are right angles. So using angle similarity criterion, we can say these two triangles are similar. And we have studied when two triangles are similar, their corresponding sides are proportionate. And on the basis of this conclusion, we can write AB upon AD is equal to AC upon AB. And when we further simplify this equation, we are getting AB square. The square of one of the sides of this right angle triangle is equal to AC into AD. AC is the hypotenuse of this given right angle triangle ABC. Mark this equation as an equation number 1. Now let's proceed to the next two triangles. Now we are going to prove similarity in triangles ABC, again the complete triangle, and triangle BDC. I'm talking about this triangle ABC and triangle BDC. In these two triangles, we can see that angle C is common, which measures 90 degrees minus alpha, and angle CDB is equal to angle ABC. They are equal to 90 degrees. That means they are right angles. Again, using angle similarity criterion, we can prove that these two triangles are similar. I mean, triangle ABC is similar to triangle BDC. And when two triangles are similar, again we can write their corresponding sides are proportionate. That means AC upon BC is equal to BC upon CD. And when we simplify this equation, we are getting very useful result, that is BC square is equal to AC multiplied by CD. Mark this equation as an equation number 2. Now we are going to add equation number 1 and equation number 2. What we are getting on the left hand side, we are getting sum of the squares of two sides of this right angle triangle, that is AB square plus BC square. While on the other side, we are getting AC into AD plus AC into CD. Now we can take AC common from the right hand side. Then we are getting AC multiplied by AD plus CD. AD plus CD will be replaced by this complete line segment, that is hypotenuse of this right angle triangle ABC. So finally we are getting AC square on the right hand side of this equation, and what we are getting? The required result. That means the square of hypotenuse is equal to the sum of the squares of the remaining two sides of this given right angle triangle, and this is the proof of Pythagoras theorem. I hope you understood this question. Let's talk about marking scheme of this question. So we are starting with the very first step. When we are writing the given information to prove, and we are drawing the diagram, and we have done this step of construction. So this will give you half mark. Next half mark when we are going to prove similarity in two triangles. So ये बहुत इंपॉर्टेंट स्टेप है कि कौन से दो ट्राइंगल्स हम चूज करते हैं सिमिलर प्रूफ करने के लिए, जिससे कि हमें रिक्वायर्ड रिजल्ट मिल जाए. तो ये स्टेप आपको हाफ मार्क देगा. When we are proving AB square is equal to AC into AD, so this will give you next half mark. अगला हाफ मार्क आपको इन दो ट्राइंगल्स को चूज करने पे मिलेगा जिनमें हम सिमिलैरिटी प्रूफ करने जा रहे हैं. That means I am talking about triangle ABC and triangle BDC. और इनको सिमिलर प्रूफ करने के बाद जो रिजल्ट मिला, ये मुझे अगला हाफ मार्क देगा. And rest half mark is based on the final result when we are proving the square of hypotenuse is equal to the sum of the squares of the remaining two sides. So in this manner we can score 3 out of 3 for this question based on the concept of triangles, and this is a Pythagoras theorem. I hope it is clear to everyone. Now let's proceed to the next question.